In this lesson, we are going to be expanding logs, where it means we're going to be using these properties and taking things that are kind of condensed together, and we're going to be breaking it up as much as we possibly can. So here's kind of how I go about doing this, is that I see that there's two pieces, I'm going to have two logs in the end. I see that there's three individual kind of pieces here, I'm going to have three logs in the end. I have two pieces, I'm going to have two logs. So I have two pieces, so I'm going to break this up, and I have division. So division is going to break up into subtraction. So I'm going to have log base t of 8 minus log base t of w. Okay, and then here I have two pieces because it's 0.2 times x. So those can definitely be broken apart. So we got log base 5 of 0.2 plus, because it's multiplication between the two, log base 5 of x. All right, so here we have a combination of pieces. So I'm seeing that I have three individual pieces, and they have exponents on them. So it's actually going to be two steps. First step is I'm going to break everything up. Anything that's multiplication is addition, and anything that's in the denominator is a subtraction. So I do cheat it a little bit, because if I have multiple things in the denominator, that just means I have multiple subtraction pieces. There's a couple different ways that you can look at it, but I just look at it as anything on the top is positive, anything on the bottom is negative. So first thing I'm going to do is I have three pieces, so I'm going to rewrite this as log base a of x squared plus log base a of y to the fifth minus log base a of z to the fourth. And I subtracted strictly because it was in the denominator. So now I'm going to pull all the exponents off. So logs don't keep exponents, so I'm going to pull those off and just put them in the front. So the 2 is going to go in the front, the 5 is going to go in the front, log base a of y, and then minus 4 is going to go in front, log base a of z. And that's the best I can do. There's no more exponents left over, and all these pieces are all individual with no multiplication or division whatsoever on them. And then this thing is a little bit tricky. I'm going to have two pieces added together and one piece subtracted. So I have three pieces, three individual logs, but I got this radical. So first thing is I need to rewrite the radical. And rewriting the radical is just taking the cube root and writing it as a 1/3 power. So first thing that I can do is I can pull that 1/3 power off. Now this is not the only way to do this. You could take that 1/3 power and bring it into all those exponents and make these fractional exponents, but you do not have to. So I didn't do anything other than I pulled the exponent off of the log. So now I'm going to separate everything out. So I'm going to have log base a of a to the second plus log base a of b minus log base a of c to the fifth. All right, so now I can pull all these exponents in front. So I have a 1/3. Oops. And I got to pull all the exponents in front. So the 2 is going to come in front here. And interestingly, this thing is going to become a 1 here. So that's going to go away. And then there's nothing to pull in front of this. So that's just going to be log base a of b. And then minus the 5 that's going to come in front, log base a of c. So this is a property that if the base matches the value, that's just equivalent to 1. So then that's just 2 times 1. So technically that's probably okay as an answer, but if you want, you can distribute this in, because if you would have brought this power in at the very beginning, you would have had a 2/3 power, a 1/3 power, and a 5/3. that comes from these pieces. So this might be okay for an answer, but you can also distribute it in. This is just a 2 times 1/3. So that's a 2/3 plus 1/3 log base A of B, and then minus 5/3 when you take 1/3 times 5 log base A of C. All right, so this one's probably okay in an answer. Just kind of clean that up just to make it just a 2. But if you don't want any parentheses at all, you can distribute the original exponent, or if you would have done that at the beginning, that's how you would have got that as well. So we have 2 more. So we have 2 pieces here. So I'm going to have 2 individual logs. So then that's going to break into the natural log of x plus the natural log of y to the negative 8. There's no division, so that's going to just stay on the top, and then I pull the exponent off. So the natural log of x minus 8 natural log of y. So here's the thing about this one is you could have rewritten this, by the way, as the natural log of x over y to the positive 8 if you wanted to, and that would have made your subtraction happen. So that negative exponent really would have gone into the denominator, and the denominator would have forced a subtraction to happen. But it still all works out. So if you want to take these problems and just maybe make it easier for yourself, you can pull everything up and just have 4 individual log pieces. So I'll do that on that one as well. So let me rewrite it as I have 1, 2, 3, 4. So I have 4 values, so that means I'm going to have 4 logs. Log base B of A plus log base B of y to the 5th, and then minus, because of the fact that they're down in the denominator, log base B of m to the 3rd minus log base B of n to the 4th. So now I'm going to pull all the exponents off. There's nothing to pull off here, so that doesn't change. And then plus 5 log B of y minus 3 log B of m minus 4 log B of n. Okay, so like again, if you want to, you don't have to have any division whatsoever. So if you want to rewrite this, you can absolutely rewrite this as a y to the 5th, m to the negative 3rd, n to the negative 4th. And there's your 4 pieces, there's your negative 3, there's your negative 4, and it would still get you the exact same result. So whatever makes more sense and whatever works for you, you're good. All right, that was expanding logs.